Hello, trigonometry. Just want to let you know for 8.1a, this is going to be 2 videos instead of just one giant one. So in other words, I'm going to take this and split this lesson into 2 parts, and this is going to be part 1. So before we begin, I want to make sure you have a calculator that can do sine and also sine inverse. You can still use the calculator I used in the previous lesson. Again, you can just go to eweb.com/tool/calculator, and it will give you this calculator where you can do sine, and also you can do inverse sine. So inverse, previous answer, closed parentheses, and there you go. So, and also I want you to make sure that your calculator is put into degrees. Go ahead and do that now. Make sure your calculator is in degrees. All the examples I'll be showing you today, all the examples will be in degrees. So make sure your calculator is set to degrees so you don't have any issues. All right? So now, that's all you'll need. All you'll need is a calculator. You will not need your unit circle, and you will not need your formula sheet. So let's begin. So first, I want to fresh you up with a bell ringer. Given these 2 sides of the following right triangle, determine the length of the remaining side. And of course, for any right triangle, there is a handy-dandy theorem that can help you find the third side. Or in other words, the Pythagorean theorem. A squared plus b squared equals c squared, where the c squared is always the hypotenuse. And in this case, we are looking for the hypotenuse. So what we'll be looking for is c. So we'll go ahead and label this side a and this side b. Doesn't really matter which one. And then let's go ahead and plug the numbers in. So a squared is going to be 5 squared. B squared is going to be 12 squared. And then we just got to solve for c. 5 squared will give you 25. 12 squared, that'll be 144. Oops. And that's still equal to c squared. If you do 25 plus 44, that should give you 169. And we almost have the c, we just have to get rid of the power of 2. And you do that by taking the square root. And you should get, when you take the square root of 169, you should get 13. So 13 is the hypotenuse, or the missing side. Done. Now, I have a confession to make. This Pythagorean theorem, this lesson actually does not require it. Here's why. The Pythagorean theorem can only be used on right triangles. I can't spell triangle. So in other words, the only reason we are allowed to use the Pythagorean theorem is because our triangle had a 90-degree angle in it. What if, for example, I gave you a triangle that was like this? And let's say these 3 angles, none of them were 90 degrees. If we don't have a single 90-degree angle, then I can't use it. Well, shucks, Miss Shulin. All the angles you've ever given us were triangles that had 90-degree angles in them somewhere. What are we going to do now? Well, that's what this lesson is all about. How to approach triangles that are not right. Or in other words, I want to show you how to solve for any triangle, not just the right ones. So far, we have worked with trig functions and identities in order to solve problems involving the angles and sides of right triangles. So far, that's the only triangle we worked with, was right triangles. Today, we're going to learn about tools to analyze oblique triangles, or just triangles that don't have a 90-degree angle. So in this example, as you know, there's always six quantities that each triangle have. They will always have 3 sides and 3 angles. Now, if we know one side in any 2 of the other 5 quantities, we'll be able to determine the remaining 3 using the laws of sine and cosine. I bet some of you probably remember hearing that word back in geometry. It was a topic that Mrs. Bader did teach. So today we're going to be doing some refreshers on that. And specifically for part 1, we're going to be looking at the law of sines. The law of cosines is going to be part 2. So one thing about the law of sines is basically they're interchangeable. So in other words, if you look at the law of sines, you have sine of big A over little a is equal to sine of B over little b, and it's also equal to sine of big C over little c. And what I mean by interchangeable is that if you wanted to flip this so that a little a is on top and the sine big A is on bottom to become this, you could totally do that, as long as you do it for the B's and the C's. So in other words, if you have a preference, it doesn't matter which law of sines you use. You could use where the sine is on top, which would be this, or you could use it where the sine is on bottom, which is this. Doesn't matter what you prefer. I just want to let you know for this video, I'm going to get into the habit of using this one, but if you prefer to use this one, go right ahead. But just for this video, I'm going to use this version of the law of sines. And also something I want to clarify. There is a huge difference between uppercase letters and lowercase letters. Uppercase letters will always be the angles. The lowercase letters will always be the signs. So the big letters, again, will always be the angles. In this case, they'll be in degrees. And then the lowercase letters will always be the sides. And also the position of your sides is hugely important. Basically, if you have big A and little a, they need to be opposite of each other. So wherever big A is, or that angle, its opposite side needs to be little a. Same thing with B. If big B is over here, its opposite side better be little b. And of course, if you have your big C or your angle C, its opposite side should be labeled as little c. That's going to be very, very, very important. So that's something, just a couple things we need to talk about. And one more thing that we need to talk about before we talk about some examples that you probably remember from geometry. For any angle you have, if you were to add all the angles together, they should always add to 180. So like if I gave you that angle A was 100 degrees, and that angle B was, say, 30, then you could easily use this fact to find out what angle C is. So like, for example, you can subtract 100, you can subtract the 30 over, or in other words, subtract 130 over, and you'll get that C should be equal to 50 degrees. Using that fact, finding the angle should be easy because you know all 3 angles have to add to 180. We will be using that in this lesson, so just a heads up. So, enough of vocabulary and terminology. Let's go to an actual example. So let's say we're given this triangle, and we're given one side and 2 angles. Given this information, we need to find the remaining 3 values. So let's first just look at what we have. Right now, we have little a, and little a is going to be the side of 3. We do not have the other 2 sides, little b and little c. So let's just say off the side, we need to find what little b and little c is. We are also given 2 angles, big A and big B. So for angle A, or uppercase A, I'm going to put 30 degrees. For angle B, we got 45, but we don't know what the third angle is, angle C. So we're just going to say over here, we need to find angle C, or big C. And of course, since it's an angle, we're going to make sure we have to put the degree symbol for that. Okay, so using this information, and usually the key is that you can only, basically, you can only use sine whenever you have a pair. Like here, we have big A and little a. So in other words, we have a pair of A's. And as long as you have a pair where you have a big A and a little a, or big B, little b, big C, little c, as long as you have a pair, we can use the law of sines. So I'm just going to go ahead and write the law of sines real quick. So sine of big A over little a, so sine, and then is equal to sine of big B over little b, and then that's going to be equal to sine of big C all over little c. And let's go ahead and fill in the information we have. We have a little a, we have a big A, and we have a big B. Let's go ahead and fill out those pieces of information in. So here, sine of big A, where big A is 30 degrees, and that's all going to be divided by little a, where little a is 3. And then over here, we're going to have sine of big B, where big B is 45 degrees. And then that's going to be divided by little b. We do not know what little b is, so I'm just going to leave that as is. And then over here, sine of big C, which we do not have, and then sine of little c. So, now I do want to point out, since we don't really have anything for C, if we're missing both the C's, then this is actually going to be useless. We cannot do anything with the law of sines unless we have one of the C's. So we can actually ignore this part for now. And let's just focus now on this part. Sine of 30 over 3, sine of 45 over b, or little b. And our goal is we're going to try and use this to find out what little b is. And the best part is that for solving for little b, you can easily find b by cross-multiplying. That cool little cross-multiplying trick that everyone loves. So let's go ahead and try it. So b times sine of 30, I'm going to write that over here, b times sine of 30 degrees, and then that's going to be equal to 3 times sine 45. So 3 times sine of 45 degrees. All right. No more fractions, that's really nice. And we almost have b by itself, we just have to get rid of the sine of 30. And the best way to get rid of it, to get b by itself, is to divide it. Because we're multiplying sine, the opposite would be to divide it. So let's divide sine of 30 to both sides. So then this cancels, and all you have is this. That, give me a second, little b is equal to 3 times sine of 45 degrees all over sine of 30. And that's going to be little b. But of course, you can't put that in the Hawks program. You're actually going to have to type that out, and you will get a decimal. So let's go ahead and see what that's going to be in the calculator. So sine of 45 degrees over sine of 30. Calculator. All right, so clear that. So 3 times sine of 45 degrees. Again, we are in degrees. Good. Close parentheses. Okay, and then we got to divide by sine of 30. So divide that answer by sine of 30. Close parentheses, press enter. And that's going to give us our B, 4.2426. Now, I'm pretty certain, if I remember correctly, the Hawks program will want you to round to 3 decimal places. So in other words, you'll take a look at the 4th decimal, that's a 6, that's going to tell you to round up. So you should write 2 or 4.243 as your little b. So let's go ahead and write that on the slide. 4.243. Okay. Go up here, little b. It's going to be 4.243. All right. One answer down, two more to go. Now, I'm going to go ahead and erase all the work that I just did. You guys don't have to. I'm just going to erase the work so I can make room for the next problems. All right. Okay, there we go. So now, we need to find little c and big C. And again, we couldn't really use law of sines yet, as you saw, because, well, we were missing both the c's. We had to have one c to find the other. But there is a nice little trick that can help us find c. And you probably already know what it is. For those who've already figured it out, awesome. If you haven't figured it out yet, remember, all three angles, big A, big E, big B, and big C, have to add to 180. And you have that A is 30, and you have that B is 45. Given that information, you can easily find C. Just subtract the 30 over and subtract the 45 over to this side, and you should get that C is 105 degrees. As long as all three angles add to 180, you're good. All right. So with that information, we can go ahead and find little c. So let's go ahead and do that using the law of sines. So sine of A over little a, sine of B over little b, and then sine of C all over little c. Fill in the information. Here for A, we'll have sine of 30 all over 3. Over here, sine of B is going to be sine of 45 degrees all over little b, which little b we got 4.243. And then sine of C will be sine of 105 all over little c. And our goal is to find little c. Now, some of you probably realized by now is that I don't really need all three sine parts to justifying c. I only need one of these to help me figure it out, because then you can just cross multiply and be done. And I'm going to choose to keep the sine of A over little b. If you choose to keep the sine B over little b, go ahead. I'm just randomly picking that I'm just going to decide to eliminate the second one and just bring these two together to solve. Doesn't matter which one you get rid of. So sine of 30 over 3, and that's going to be equal to sine of 105 all over little c. And then to solve for c, you know what to do. Cross multiply. So cross multiply, you'll get c times sine of 30 degrees. And then cross the other way, you'll get 3 times sine of 105. And then to solve for little c, you just divide by sine of 30. There you go. So to find little c, you just got to solve this stuff. 3 times sine of 1 over 5 divided by sine of 30. Let's do it. I'm going to go to the calculator real quick. All right, clear. So do 3 times sine of 105, close parentheses, and then divide that by sine of 30. And that's going to give me 5.7955, which if we round up to 3 decimal places, that's going to give us 5.796. And that will be our little c. All right, let's go ahead and write that on the PowerPoint. That little c is going to be 5.796. And that's what you'll type into the Hawks program. You'll type that little b is this number, little c is this number, and your big angle C is 105 degrees. And there you go. Now you know how to use the law of sines. Just plug it in, cross multiply, and solve. Okay, so I'm going to grab a cough drop real quick. But some of you can go ahead and start on the second one using very similar tactics. All right. So this time, well, ignoring this stuff up here, this time we're given one angle, and this time the angle is big B. So big B is going to be 115 degrees. Again, opposite little b. And we need to find the other two angles, big A and big C. So I'm just going to write that off to the side. We need to find big A, we need to find big C. That is not a big C. That's a big C. And then in terms of the sides, we're given two of them. We're given the opposite angle of A, which is little a, which is 4. And then the opposite side of big B, which is little b, which is going to be 5. And then all we're missing is little c. So those are the three parts that we are going to solve for. And real quick, let's see if we have a pair. And sure enough, we do have a pair. We have big B and little b. And as long as we have a pair, that means we can use the law of sines. So, again, since my pair is B, I'm going to start off with big B over little b this time. I don't have to start with big A over little a. And in this case, I can either put sine of A over little b or sine of A over little a or sine of C over little c. I probably can't use the C's because, again, I need one of the C's to find the other. So it looks like the only thing I can use is sine of A over little a because I have little a. And if I have little a, I can find the other a. Ugh. I've been saying letters a lot in one sentence. Blech. Whew. But anyway, we don't need sine of C over little c yet. We can just use these two and go from there. All right, so let's plug in our values. So here, sine of big B will be 115, all over little b, where little b is 5. Over here will be sine of A. We don't have big A yet, but we do have little a. Little a is 4. All right, so now we plugged everything in. Now we can solve and find out what big A is going to be. And let's first start by cross-multiplying. Multiply this way. You'll get 4 times sine of 115 degrees. And that's going to be equal to that, which is 5 times sine of A. All right, so again, our objective is we need to solve for A. Well, let's not deal with the sine just yet. For now, let's do the easy stuff and get rid of the 5. And since it's being multiplied, you have to divide to get rid of it. Okay. So continuing from there, we currently have 4 times sine of 115 degrees, all divided by 5, and that's going to be equal to sine of A. Now let's go ahead and figure out what this part is. Let's find out what 4 sine 115 divided by 5 is. So let's go to the calculator. So 4 times sine of 115, close parentheses, and all that divided by 5. And that's going to give us 0.7250462296293. Whew, that is a decimal. And the sad thing is we can't round that. So in other words, write this whole thing out. No, you think I'm kidding. Write out the whole decimal. 0.72506229623. Just to double check I did that. 0.7250622. Hang on, was that a 96 or was that a 46? Let's check. Oh no, that was a 46. That should be a 46. Okay. 7, 2, 5, 0, 4, 6. Okay, that's better. And all of that's supposed to be equal to sine of A. Now, the reason why I can't round that answer yet is because I'm not done yet. I still have to get rid of sine. And some of you might remember, how do I get rid of a sine? By taking its opposite. And its opposite, not twin, I'm not talking about the opposite twin, I'm talking about its reciprocal. Or not the reciprocal. I'm talking about the inverse. That's what I meant to say. You gotta take the inverse of both sides. So then it will cancel the sine on this side, and you'll just have A. So then our calculator, we gotta do sine inverse of this whole decimal. So let's do it. Now you don't have to type out that entire thing out, or that entire decimal. What you can do is first do inverse sine, and then go to this blue button that says answer. It'll take your previous answer, which was the 0.725 blah, 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 and it will go ahead and plug it into the inverse sine. So you don't need to type in all those decimals. So sine inverse, previous answer, press enter. And there you go. It'll give us our angle is 46.4726, which if you round, gives you that big A is going to be 46.473 degrees. And that is our angle A. So let's go back to the slide. We'll type that in for big A. Big A will be 46.473 degrees. Nice. So fair warning on that. You will, in some cases, you will have to use sine inverse, especially if you're looking for an angle and not a sine. So just wanted to point that out. Now we got one of our answers. Now let's find the other two. Again, just going to erase some stuff just to make room. Okay. So now, we need to find either big C or little c. I wonder if I can find big C by using 180. Or in other words, A plus B plus C equals 180. And lucky for me, I do have two angles. I have that my angle A is 46.473 from the previous answer. My B is 115 plus C is equal to 180. Then there, I just have to solve. And yes, your C will be a decimal. So you got to do 180 and then subtract the 115 over, and then subtract the 46.433 over. And this is what you should get for big C. Big C should be 18.5. Hold up, I think I did a typo. Give me a sec. There we go, that was a typo. It should be 46.473. I put a 3 instead of a 7. There we go. Okay, so that should fix it. So you should have 18.527. And that's what you have for C. C should be 18.527 degrees. All right. Now that part's really easy. As long as you have two angles, you can easily find the third. All right, now moving on to our final. We need to find little c. And I'm going to go ahead and use my original pair to help me out. So in other words, I'm going to use sine of b over little b. And since I'm finding little c, I'm going to use sine of big C over little c to help me solve. And let's go from there. So first, sine of big B will be 115, and our little b will be 5. Then you gotta do sine of big C, where big C is 18.527 degrees, and that can be divided by little c, which we will be solving. And then from there, we can cross multiply. Cross multiply this, and you'll have c times sine of 115. Cross multiply this, and you'll get 5 times sine of 18.527. And remember, our goal is to find little c. So I'm going to go ahead and divide sine of 115 to both sides. Okay. So with that, you should have, okay, erase all that. So whatever sine of little c is, it's going to be equal to what we solved for this. So let's go ahead, type on the calculator, see what we get. So clear, we'll do 5 times sine, was it 5 times? Yep. 5 times sine of 18.527. Yep. And press enter. And then we're going to divide that by sine of 115. Close parentheses. And enter. And we showed that our C is 1.75299, which if you round to 3 decimal places should give you 1.753 as a little c. All right, so little c, we'll write that up here, is going to be equal to 1.753. And there you go. That will be the answers that you'll type into the Hawks program. Big A, big B, or big A, big C, little c. So this example was a little bit different because you had to use sine inverse. But you guys are familiar with sine inverse. You just got to be careful with your calculations. The last thing you want to do is rush these problems. Please take your time, show your work, don't skip any steps. All right, so with that said, I'm going to go ahead and let you try this one on your own. Find the 3 missing sides. Oh, and don't be alarmed if A is a decimal or little a is a decimal. Just treat it like you normally would, like if it was just 5 or if it was just 8 or something like that. Doesn't matter if it's a decimal, just keep it as 5.5 and solve it like you normally would. Go ahead, pause the video, and then try it for yourselves, and then check. All right, you should have resumed the video by now. So you probably guessed the sides that we're missing. We are missing 2 angles, big B and big C, and we're also missing little c. If you want to just go ahead and check your answer real quick, for big B, you should have 28.189 degrees. For C, you should have 31.811 degrees. And then for little c, you should have 3.348. Now, if you already got that, you feel comfortable with how you did, you can go ahead, move on to the next example and just skip over the next 3 or 4 minutes. If you want me to walk through this example, keep watching. So for this example, I have a pair. a pair of a's. So that means I'm going to be using sine of big A over little a. And my third side, or my third part, is little b. So I'm going to use that to find its pair, big B. So let's go ahead and equal that to sine of b over little b. We'll do sine of c over little c later. So now plug in the numbers. You'll have sine of 120 degrees all over little a, which is going to be 5.5. Then you're going to do sine of big B over little b, where little b is 3. And then from there, cross multiply. Here you'll have 3 times sine of 120 degrees. This one, you'll have 5.5 times sine of big B, and we'll go from there. So here, before I do anything else, before I take care of the sine, I'm going to divide 5.5 to both sides. So over here, I'll have 3 times sine of 120 degrees, and that's all going to be divided by 5.5. And then that's going to be equal to sine of big B, sine of big B. Now, I'm not going to go ahead and type in the decimal yet. I'm going to go ahead and show you to get rid of this sign, just like before. I'm going to take sine inverse of both sides. So I'm going to take all of this, and whatever that answer is, I'm going to take the sine inverse of that. So then these will cancel, and now I just have big B on the right. And then whatever this comes to, that's what big B is going to equal. So now, let's go ahead and take care of this part. Let's take care of the 3 times sine 120 over 5.5, and then once we have that decimal in our calculator, we'll then do the sine inverse of that answer. So let's go ahead and do that. 3 sine 120 over 5.5. So, clear. 3 times sine of 120, and we're going to divide that by 5.5. Enter. Just going to make sure that was the right numbers. Sine of 3 times sine of 120. Yep, divide by 5.5, and you get that. That will be the decimal. And now, let's go ahead and do the sine inverse of that. So, sine inverse, go to previous answer, and then close the brackets, close parentheses, and press enter. And you'll have that big B is 28.1887, which will round to 28.189. That is what your big B is going to become. All right, so now you got your big B, which, as you see, checks out. To find the big C, you again can do A plus B plus C equals 180 and go from there, and that's how you get the big C. And now to find the little c, you'll use the law of sines again. So in this case, since I'm finding little c, I'll use sine of c over little c. And I'm going to go ahead and use my pair to help solve. So sine of big A all over little a. All right, plug and chug and go from there. So, where's the rest of my work? So sine of 120 degrees divided by 5.5, big A, little a. Sine of c, where c is 31.811, and that's going to be all divided by little c. So then from here, you just got to cross multiply. So cross multiply here, that's going to give you c times sine of 120 degrees. And then cross multiply again, and you'll get 5.5 times sine of 31.811 degrees. And then to solve for little c, you'll divide by sine of 120 to both sides. So then you plug this all into your calculator, and that should give you what little c is going to become. So 5.5 times sine of 31.811. So 5.5 times sine of 31.811, close parentheses, enter. But we're not done yet. We still got to divide by sine of 120 degrees. So take the answer, previous answer, divide by sine 120, and there you go. C, little c, is going to be equal to 3.3476, which rounds to 3.348. And there you go. Oh, and just so you know, I double-checked all these answers before I started these videos. These are the correct answers, I promise you. I have the answer sheet with me. And sure enough, that's how you get little c. All right, that was just a refresher of the examples we've been doing. Now, I'm going to show you a couple word problems. And I went ahead and did all the sketching for you just to make the video go a little bit smoother. So in this example, we have Brandy is flying an airplane and is descending at a 10-degree angle towards a runway. She can see a lake behind her at a 50-degree angle that is 500 feet away from the runway. With this information, how much farther does she have to fly until she lands? And then we're going to round to the nearest 10. Okay. So here I just have a drawing of basically all the things that we talked about. We have Brandy in an airplane, we have a lake that's behind her, and we have a runway that's in front of her. So let's look at the first sentence. Brandy is flying an airplane and is descending at a 10-degree angle. Basically right now she's flying straight, but eventually she's going to have to start turning that airplane to point downwards. And specifically, how far is she going to point her plane downwards? She's going to point it downwards or make it descend 10 degrees. So in other words, she's going to make the airplane tilt 10 degrees so it starts pointing towards land, so then she could land at the runway. Mary, Mary, I need you, honey. Ah, cracks me up. And also, she can see a lake behind her at a 50-degree angle. Basically saying if she looked behind her, she would have to look down specifically 50 degrees. Or in other words, she'd have to tilt her head down 50 degrees to look behind her to see the lake. So that's where that's coming from. And we also have that the lake is 500 feet away from the runway. Or in other words, the distance from the lake to the runway, that's going to be 500 feet. And then given this information, how much farther does she have to fly until she lands? Okay. Okay, so let's first, before we get to the question we're trying to solve, let's just now look at what we have and see what we can come up with. Well, I do want to say this. So assume at this moment, before she starts descending the plane to run towards the runway, assume that she's flying straight. Or in other words, let's assume, as of right now, let's assume that she's parallel to the Earth. And the fact that she's parallel to the Earth, meaning we currently have two parallel lines, that's something that we can use. That's something we can use from geometry. Some of you may remember at the very beginning of geometry, Ms. Bader teaching you how corresponding angles are congruent, how alternate interior angles are congruent, and how you have two supplementary angles or I can't remember the word for it. Not alternate, but basically if you have two interior angles within the same section, they're supplementary. But anyway, what we need to understand here is using those postulates from geometry, you probably recognize these two angles are alternate interior angles. And by the parallel postulate theorem, these two angles are congruent or the same, meaning that this angle should also be 50 degrees. And that's not the only congruent angles. We got this angle and this angle right here. These two are alternate interior angles, which means they should also be congruent. So if this angle is 10 degrees, so should this one. Okay, Miss Shulin, cool. We just found that alternate interior angles are congruent. So now I got two other angles, one that's 50 and one that's 10. How does that help me here? Patience. It'll all come together soon. The reason why I pointed out those alternate interior angles is because if you look closely, we have a triangle. And now we have a triangle with two angles, which means we can now find the third angle. Because remember, angle A plus angle B plus angle C, they all have to add to 180. So given that information, 50 plus 10 is 60, which means A has to be 120 degrees. And that will make sure that these angles add to 180. Okay, cool, Miss Shulin. We now have a triangle and we now have three angles. How, again, does that help me solve the problem? Because remember, the problem is, well, let's look. Our question is, how much farther does she have to fly until she lands? Or in other words, if she's right there, how much farther does she have to fly until she reaches the runway? Or more specifically, isn't that kind of the same thing as looking for a side? I'm literally finding the side of the triangle that measures the plane to the runway. So in other words, I have to figure out what this side is. And haven't we been doing that the last three examples? We've been finding the sides and the angles of any triangle. Yeah, we have been. You literally just have to use the law of sines. But wait, Miss Shulin, for the law of sines, I have to have a pair. Do I have a pair? Well, let's find out. Well, here I got big A, little c. Big A needs a side. Oh, look, its opposite side is little a. And little a is 500. I have a pair. I have big A, little a. Boom, I have a pair. So that means I should use sine of A over little a. And, well, let's go ahead and label the other sides. If this is big B, that means its opposite side, or this side over here, has to be little b. And this is big C, so its opposite side has to be little c. But we're not really concerned about little c, because we're not concerned about the distance from the plane to the lake. We're concerned about the distance from the plane to the runway, or in other words, little b. So literally, we're just finding the side of little b, and that'll tell us the distance from the plane to the runway. So let's go ahead and use that. Let's use sine of big B over little b to help us find what little b is going to become. And with that, let's plug in our information. So sine of big A we have 120 degrees. Little a is 500 feet. And then that's going to be equal to sine of big B, where big B was 50, and then little b. So now you just got to do what you normally do. Cross multiply and solve. Let's do it. So here we're going to have b times sine of 120 degrees, and then that's going to be equal to 500 times sine of 50 degrees, and then that's going to be divided by sine of 120. Whoops. Gosh darn it. Can't write that correctly. Sine of 120 degrees, divide to both sides. Okay. So in other words, whatever little b is, that's going to be equal to this. 500 times sine of 50 all over sine of 20. Okay, I think you guys are comfortable with plugging in these values on your own. So go ahead, plug this into your EE web calculator and see what you get. And you should get that little b will give you 442.3 feet. Wait, Miss Shulin, I thought you said you wanted us to round to 3 decimal places. Originally, yes, but look at the instructions. Round to the nearest tenth. Tenth means 1 decimal place. So your little b, or distance from the plane to the runway, will be 442.3 feet. So round to 1 decimal place for that example. So make sure you're reading the instructions. The instructions will always tell you how much they want to round. Round to 3, round to 1, round to the 10th, round to the 100th, so on and so forth. All right, and that's how you approach that example. So with that said, I got another example very similar to that. Go ahead and do the exact same tactic. Go ahead and try it on your own and see what you get. All right, you should have tried it already. So if you want to go ahead and check your answer, let this side be little b, little a, little c. That makes this big A, this is big B, and this is big C. Yeah, I need to make that C a little bit bigger. There we go. And our main goal, again, was to find the distance from the plane to the runway. And you should have that little b, or that distance will be 189.6 yards. All right, if you got that answer, you can go ahead and move on to the next example. Just skip the next 3 minutes. If you want to see how I did this, keep watching. So let's go ahead and first write our information down. So Brandy is running an airplane and is descending at a 6-degree angle. So she's descending 6 degrees, or her plane is going to be pointing downwards 6 degrees. And of course, alternate interior angles are congruent, so that makes angle C 6 degrees. And it says that she can see a lake behind her at a 60-degree angle. So if she has to turn around and look down, she has to look down specifically 60 degrees. And of course, again, alternate interior angles are congruent, which makes B also 60 degrees. And it also tells us that the lake is 200 yards away from the runway. Or in other words, for little a is going to be 200 yards. And of course, given that information, B, C, and A have to add to 180. You can go ahead and find angle A real quick by making sure they add to 180. So I'm going to go ahead and do that right now. You should get that angle A should be 114 degrees. And look at that, you have a pair. And if you have a pair, that means you can use the law of sines. So sine of big A over little a. And for us, we are trying to find this side, or we're trying to find little b. And we can use big B to help us find it. So what's going to make that equal to sine of big B all over little b? So then you just got to plug in the numbers and go from there. Okay, so we're going to have sine of 114, and then little a was 200 yards. Big B, or sine of big B, was 60, and then divide by little b. Cross multiply and go from there. So here we have b times sine of 114 degrees. And that's going to be equal to 200 times sine of 60 degrees. All right. And then to solve for little b, you just got to divide by sine of 114 to both sides. There you go. Okay, so solve for big B. You just got to plug all of this into the calculator. 200 times sine of 60 over sine of 114. And that will give you 189.6. And that is in yards. Actually, yeah, I'm just going to double check that real quick in my calculator. 200 sine of 60. And that's going to be divided by sine of 114. Yep, that works. And again, it's making you round to the 10th, so that's why I round to 1 decimal place. So these are the typical type of examples that you'll come across in the hockey program, and you'll come across some very similar examples if you take the ACT. These are very important examples. A lot of ACTs use this type of example where you have to use the law of sines. So make sure you're comfortable with the law of sines and you know how to use it. Okay, one more type of word problem to go over, and then part 1 will be done. So here we have a little kitten, Casper's kitten, ran out of the house. It ran 25 feet, turned and ran 12 feet, and then turned 110 feet, and then turned 110 degrees to face the house. I have a feeling this cat was probably chasing a squirrel or a butterfly or a bird of some sort to have it run around like this. It's the only explanation I can think of. But anyway, given this information, once your cat has ran all over the place and has turned all about, how far away from the house is Casper's kitten? Given this information, we're going to round to the nearest 100. Okay, so let's say the cat is right here when it gets out of the house. We're first told that it's going to run 25 feet in one direction. And then it's going to do a turn right here. We don't know how large that turn is, but after it turns, it's going to run in a different direction, 12 feet. And ignore that part right there. 12 feet is right here. So now the cat is right here. The cat is not going to move. It's not going to run left, right, up, or down. But it's going to basically turn its head 110 degrees so that its head is now facing the house. That's basically what the problem is saying, is that the cat's not going to move, but it's just going to turn its head 110 degrees so that it's no longer facing this way, but it's facing this way. So, given that information, we want to know how far from the house is Casper's kitten. Round to the nearest 100. So, before I begin, I'm going to first start just labeling everything. Like, for example, I'm going to make this angle A, I'm going to make this angle B, and I'm going to make this angle C. And while I'm at it, I'm also going to be labeling the other sides. The opposite angle of A is over here, so that means this will be little a. C's opposite angle is this way, so that's going to make this little c. And then big B, its opposite side is over here, so that's going to be little b. If you take a look at this information, it looks like that, oh, real quick, before we move on to labeling, I want to point something out. Do you guys know the angle of a straight line? Like if I gave you a straight line and I asked you how many degrees is that? How many of you remember how many degrees that is? If you need a refresher, it's 180. Because if you remember, a full circle is 360. But if you only do half a circle, it's a straight line, and half of 360 is 180. Now take a look at this. Take a look at these two angles I've drawn here. And they come to a straight line. So if this is 110 degrees, whatever this angle is, has to add to give a straight line of 180. So in other words, our C has to be 70 degrees. That's a big help right there, that we have an angle. So in other words, like say we have two angles, this angle plus this angle has to equal 180 if it makes a straight line. So 110 plus 70 will make a straight line of 180. That is going to be a big help. So now that I have all that written down, let's write down the angles and sides that we're missing. So now I have angle C, but I'm still missing angle A and angle B. And it looks like I have little c and little a. I'm just missing little b. Okay. So these are the information. These are the missing pieces. But Miss Shulin, do I have to find all three? I thought we only had to find the distance from the cat to the house, because that's what it's asking. How far away from the house is the kitten? So if the kitten is currently right here and the house is here, don't we just need to find the distance? Don't we just need to find little b? Well, technically you're right. We really only need to find little b. But here's the thing. We can't find little b yet until we find its pair, because we're missing both big B and little b, and I can't find one until I find the other. Okay, Miss Shulin, I just need to find big B. So let's do A plus B plus C equals 180. So I don't have an A yet. I don't have a B yet. I just have a C, which is 70. And wait a minute. Yeah, I kind of need to have a second angle before I can find the third. Or in other words, in order to find big B, I need to find big A. So the way they set up this problem is that you're going to have to find two other pieces of information by yourself before you can find the answer you're looking for. That is a typical problem they'll throw on the Hawks program, and potentially on the ACT. Just a heads up. So with that information, we have to find angle A first. So let's go ahead and do that. So I know for a fact that I need to find big A. So I'm going to use the law of sines. And real quick, let's see if I have a pair. And it looks like I have big C and little c. That's my pair. So I'm going to use sine of big C all over little c to help me solve. All right, let's write those in. So I don't have sine of big A, but I do have sine of little a. Little a is 12, or 12 feet. Sine of big C, we just said, was 70. And then sine of little c is going to be 25. Yep, little c is 25. And then from here, we can cross multiply and go from there. All right, Cross multiply first, you'll get 25 times sine of big A. Cross multiply here, 12 times sine of 70 degrees. And let's go ahead and do the easy stuff first. Let's go ahead and divide by 25 to both sides. So now over here, all I have is sine of A, and that's going to be equal to 12 times sine of 70 degrees all over 25. And again, I need to find sine of big A. And to find sine of big A, I got to take the sine inverse of both sides. And once I do that, sine inverse of both sides, I'll have big A by itself. So now all I got to do, plug all this to the calculator, and once I have that answer, take the sine inverse. Let's go ahead and do that. So 12 sine of 70 divided by 25. 12 sine of 70, close parentheses, divided by 25. And you get that decimal. Then we'll take the inverse of that. So sine inverse of the previous answer, close parentheses, enter. And that's going to give you 26.811. And again, round to 3 decimal places for this example. Well, actually round to the nearest hundredth. So, what did I say the answer was? Right. The answer was 26.811, or just 0.81, because it says round to the hundredth. So let's go ahead and write that in for big A, 26.81. 26.81 degrees. Okay? So now we have big A. We can now use that to find big B. So in other words, you can do A plus B plus C equals 180 now, where you have A and you have C. You can use it to find big B. And I'm going to go ahead and calculate that real quick. So 180 minus 70, and then minus that from 26.81. And then you should have 83.19. And that's big B. And now that we finally have big B, we can use it to find the answer we've been looking for. We've been looking for little b, or the distance from the cat to the house. So now, we can again use the law of sines. So, sine of big B over little b, because again, I'm trying to find little b. And I'm going to go ahead and use my original pair of sine C over little c to help me out. So sine of C all over little c. Let's plug in the numbers. So sine of big B is 3.19. Little b, do not know. Sine of C is 70, and little c, 25. Cross multiply. 25 times sine of 83.19 degrees. That's going to be equal to b times sine of 70 degrees. All right, where was I? So, solving for little b, you just got to do 25 times sine of 83.19 divided by sine of 70. Okay, type that in your calculator. I know you guys can do it. So 25 sine of 83.19, enter, and then you're going to divide that by sine of 70. And that is going to give you, for little b, rounding to 2 decimal places, 26.42 feet. And that is what we're looking for. Basically saying the distance from the cat to the house is 26.42 feet. And there you go. So now, go ahead, we'll try one more, just like this. Joey's guinea pig ran out of the house. So right here, it runs out of the house. It's going to run 12 feet this way. Then it's going to turn and run 13 feet in this direction. And then once it's right here, it's going to turn its head 140 degrees so that it now faces the house. So it doesn't face this way anymore, it faces this way. And then given this information, we want to find the distance from the guinea pig to the house. And to start off, you know that this angle has to add to 180 because of the straight line here. So this has to be 40 degrees. And again, go ahead and do labeling. This is big A, big B, and this is big C. So that makes that side little a, this side is little c, and that side is little b. So now, go ahead and do what you got to do. Find out what big little b is. What is the distance from the guinea pig to the house? Go ahead, do the rest from there, and then I'll show you the answer. All right, so you should have your answer. So, real quick, you had to find big A, and then you had to find big B, and then you had to find little b. If to find big A first, you should have gotten 44.135 degrees. For big B, you should have got 95.865 degrees. And for little c, or little b, you should have got 18.57 feet. So in other words, for your final answer, the guinea pig is 18.57 feet away from the house. Again, you do the exact same thing we did on the previous slide, on the previous example to find it. If you have any questions on this last example, email me and I'll walk you through it. I actually am running out of time to work through the rest, but basically that is part 1. We'll do part 2 soon, where we work with the law of cosines. I'll talk to you guys later. Have a good day.